Hey, once again, 123, 123.
But it's already been a year since the launch of Apple's Vision Pro headset.
Oh my gosh, so I'm live again for the second time today. I think I've solved the issues I've had with the camera, at least for now. And I've switched to USB-C streaming since the ZV-10 can do that. I'm not doing this via Elgato capture card, we'll see. It's been turned on for the past 20 minutes and it hasn't been showing any signs of overheating, so we'll see. Also, I've seen some advice that told me to take out the SD card from the camera if you're not doing any recording. And I've also opened the preview display. That way the screen is not catching any heat that might come from the body of the camera. So we'll see how that goes. As for what we'll be doing next, I was thinking that I might do some YouTube catch-up and watch some tech YouTube. Maybe not really react, we'll see how that goes, if I have any interesting input. But I do think that some of those videos are better to experience in a larger crowd, or maybe if we're talking about enterprise gear, I might have some interesting input. We'll see. Also, it would be really interesting if you could share right now during the stream or later if you're watching, what other tech YouTube channels you're watching, because I think I do have the standard mix of tech YouTubers. You know, Gamers Nexus, Level 1 Techs, Serve the Home. I think this is like the bread and butter of the professional or a proper tech YouTube that everybody probably is watching. But I'm interested, does anybody have other suggestions when it comes to that? Well, we'll see. I think we might start with Level 1 Techs with the Supermicro JBot disk shelf. Storage is always very interesting to me, so we'll see how that goes.
90 18-terabyte hard drives, 1.6 petabytes of raw storage. You can just buy this? Yeah, serverpartdeals.com. We're gonna do a build. It's time to build a petabyte server. Don't worry, I'm gonna walk you through it. You can do a petabyte of storage in just 4U. Yeah, you can actually do 2.5 petabyte. I mean, if you get super insane capacity drives, we're gonna use...
Yes, I think I've showed that in the supercomputing video. Also, I think I've quite recently have gotten the most interesting marketing email as of late, which basically said that, yeah, you can have those crazy densities and you can have like 30, 28 or 30 or whatever terabyte drives in those shelves. The problem is that those are SMR drives. And basically, if you don't know what SMR is, well, SMR is a technology of writing to disk platter. I don't really want to go into too much detail, but basically SMR means slow. You don't really have like exact same performance during the whole disk write, and it's especially hurtful in enterprise setting where you have like RAIDs, etc., where if you like basically have one disk that goes kaput and you replace it with another, the RAID rebuilding process takes way longer, on SMR drives. That's basically the main example that's being given. So basically, yes, those drives exist, like 28, 30 terabytes. They do need specialized non-free file systems or management solutions to work properly. I mean, we'll see what Level 1 Techs has to say about that.
18 terabyte drives. This is a chassis from Supermicro. It's actually a disk shelf. It's not a server. And that's what I recommend when you're building something this insane. Come with me on a journey of exploration and learning, and you can see why I think this is the best way to approach having a petabyte of storage locally. We're going to do this because Backblaze lost some data in the cloud, and somebody I know wants to have a local copy. That's probably going to be another video in the future, but for now, let's walk through the learnings and recommendations and everything else if you're going to embark on a project like this. Why a disk shelf? I mean, what is it about a shelf of disks? It's like the name says, it's a shelf of disks.
Yeah, basically I love disk shelves. I do have some old deprecated disk shelves at work that I'm basically trying to utilize at least.
There's no computer in here. This is just the care and feeding of your actual hard drives. Why a disk shelf? Well, I've been building these things for a long time. I've helped a lot of other content creators with their storage. And for home lab and off-label use, you know, older NetApp disk shelves were the way to go. Those are the 10-year solution, 7 to 10 years ago. NetApp, you say? The venerable old NetApp. Love these.
I have this at work. Literally this.
Things. They're wonderful. I still have a few that I'm giving away to content creators and that sort of stuff. There's nothing wrong with this for a home lab or anything like that. It's 24 drives. It's just that, those power supplies have been on a long time. The interface is slower. SAS 6 at best. SAS 3 is more typical. They're not bad. It's just they're not a 10-year solution. And they're not something you would run a business off of in 2025. NetApp. It's good stuff. This is the modern 10-year solution in 2025. This kind of approach means that your storage lives here, but it's got connections to a server in the back, and so you can actually swap the server hardware independent of the storage. That makes error recovery a lot easier because the computer does something weird. This is modular. This is built to hold a lot of drives. This is way better than a chassis that is going to hold a lot of drives because it's a little bit separation of concerns. Recovery generally is a little easier, but this still has some really cool features like out-of-band management. You can plug it into the network and it'll tell you information about the chassis. It's also modular design, so the power supplies, the interface modules. This one is set up for SATA. You can set it up for SAS, serial attached SCSI, which we'll talk about, and SAS is a little bit more redundant in that you can have redundant paths to the drives and redundant connections to the drives and even more redundancy. But considering this is meant to be a mirror of information that is also mirrored off-site in a cloud service provider, we probably don't need that level of redundancy.
Yeah, so basically what he's saying, and this is especially interesting if you're like running not really disk shelves, but also storage arrays. You can basically have two of those in two separate data centers, and you can basically configure them to mirror one another. So in that case, you're adding level to redundancy. If you have like, let's say ZFS configured or whatever, you're adding another layer of security / redundancy by having a duplicate mirror copy in another location. Given that you have a link fast enough and even the link existing to connect them so they can actually mirror one another.
If you were using this for nearline storage or you wanted it to be a system that was up all the time, then maybe serial attached SCSI would make sense. There's really not a lot of cost differential between SAS and SATA, but you do physically have more hardware in the disk shelf as well, so it does make the disk shelf a little more expensive.
So what he was saying was that you have additional paths in SAS. I think I have also seen them used not only for redundancy, because basically what the SAS gives you is you can plug in SAS drive to a SATA controller, and it basically will see single one of those two controllers that SAS gives you. It works like half the time, 70% of the time, to be honest. But you can, in theory, do that, and I've seen that work. But basically, I've also seen SAS being utilized, the double controller feature, as, you know, surpassing the 6 gigabit limit of drives, which basically gives you 12 gigabits if you have like drives fast enough. You could do that with a proper SAS controller.
And let's talk for a second about SAS versus SATA. We've covered this a lot in the past. These are SAS drives, these are SATA drives. The big difference with SAS versus SATA is that SAS drives are built for enterprise reliability, and they have some different features. As a practical matter in 2025, in terms of longevity and feature set and all this sort of thing, enterprise grade SATA drives, which is what these Western Digital drives are really not a lot different than their SAS counterparts. The big differences that remain are the interface type. So they can do up to 1.2 gigabytes per second on the interface speed. Don't worry, the physical drives themselves, they're not actually any faster, it's just the interface speed. The other thing is that each of these drives support a redundant connection. So with SATA, you only have the one connection on the drive. But with SAS, there's actually two connections. The controller on this drive can be connected to up to 2 different controllers. This opens up some really interesting possibilities in terms of being able to connect this one disk shelf to a bunch of controllers. If you've got advanced software, like TrueNAS offers commercial software, this is not the free TrueNAS, but this is a paid for one. They offer solutions where you have multiple compute nodes connected to one disk shelf, which gives you a higher level of availability. Synology, they have the SA3400D. It's 2 compute nodes connected to storage, and in those cases, they require SAS drives because those are the only drives that will let you physically have 2 connections to 2 different controllers for high availability and redundancy. So if you lose one controller, the other one takes over. You can do some magic with interposers and connectivity in order to have redundant paths to a SATA drive in an enclosure, and Supermicro has some of that magic, but the single controller or single I/O module disk shelves are really not designed for that level of redundancy. You can add the features to that. This one chassis will take those upgrades, and you can do that. But for SATA drives and for the stated use case of this is a mirror of another backup, or this is where the backups will be staged from to the cloud, we don't need that level of redundancy or dual pathing. So SATA is just...
Yeah, maybe not dual pathing. I think you can find more under the multipathing. But exactly, so you could, to add to what he's saying, you can have like those 2 controllers as redundant, being redundant to one another, but also you can basically out of this JBOD have 2 physical cables going out through 2 separate paths of network switches, etc., and then going to, let's say, a router or switch or whatever, and then basically being routed or switched to a server, and in that server you can see those 2 paths, and you can also know that, hey, this is the same drive basically available via 2 separate paths. And using, for example, multipathd, there's a daemon like that in Linux, in Debian, for example, you can create a virtual multipath device, which is basically that, for example, drive, but you are like given that layer of abstraction and hiding the fact that it's available over the 2 redundant paths. What that gives you is that, for example, if you have those paths across, like, I don't know, some switches or routers, you can disable one path without the host noticing. For example, for maintenance, reboot, I don't know, somebody tripped over a patch cord, whatever. And this is super cool. I think this is also very often used, and I keep going back to that in storage arrays, where, for example, if you are doing rolling upgrade and you have everything connected via multipath from 2 redundant controllers in a storage array, and if you're doing the firmware upgrade, the one controller is installing the firmware upgrade and it's rebooting, and only after that controller is down, the second one takes over the load, and the host system keeps everything running smoothly because it's doing that over multipath. And after that first controller is upgraded, then the second one goes down and it's operating itself. But the first one has already gone up and it's taken the IO load with the multipath on the host being a director in that process, making sure that nothing is interrupted and no IO is lost.
fine. The other reason to use SAS over SATA is signal integrity. These things can push a signal a lot longer, but because we're using a disk shelf that has electronics, it has stuff in it to repeat them, and so this is a lot different than using a long cable. If you use a SAS controller in a desktop computer with a really long cable, it may be a little bit unreliable with a SATA drive, whereas with a SAS drive, it would be perfectly fine. This is owing to the different electrical characteristics between SAS and SATA. But that doesn't really matter for what we're doing here. If you get a disk shelf, you sort of sidestep all of those problems from having to worry about it versus trying to assemble it in a chassis and mixing SAS and SATA. And it's like, did you have good cable integrity and blah, blah, blah. So let's just get this thing put together and run some benchmarks. This chassis is from Server Part Deals, and it's super micro, and I've actually used this chassis before. Actually, Jake from LTT, he and I...
Wait, I think he forgot to explicitly mention that, but basically every drive that he will install in that shelf will be visible in a system he will connect it to. This will not be like abstracted as a large pool of space. Every single drive will be visible, which gives you enough flexibility to configure any file system or any RAID or ZFS or whatever you want.
I worked on it a while ago. He has some really good notes about the particular setups that we'll get into, and there's a how-to for that on the forum. But Server Part Deals for, you know, we could basically be out the door for less than half, really less than a third of the price of the equivalent system from Dell. And Supermicro is good stuff, and so you're going to be able to get parts for this chassis from now until the end of time because it is so popular in the enterprise and the cloud and everything else. See, that's the thing with the NetApp. It's like the reason you use the NetApp is because you can get parts. Oh, the power supply exploded. Oh, I'll just get another one. It's just that now there's so old and so many people are still using them that they're starting to dry up a little bit. That'll be a problem for this thing in 10 years. I want to talk about the care and feeding of a system like this because it is kind of complex. And as we do the video, it's like, oh, I've got my heavy-duty work table here. We're going to set it up on the work table and move it into place. No, this is the wrong way to do that. These drives, the thing that kills hard drives, clacking them together, just the mechanical stress of that is too much. This is probably, these are ancient drives. Don't worry about it. But also, you want to move the chassis into place and get it mounted in your rack. This is about 300 pounds. Can your rack actually handle this unloaded?
Yeah, very important stuff. Basically, like he showed the clacking of the drives. Remember that on the HDD, the drive head is literally like nano or micrometers like away from the plate. So even small G-forces can affect that and basically can make the head basically touch the plate. It's not as bad if the G-force is not big and the drive is turned off, but basically if the drive is turned on and you do like whatever clacking or vibration or whatever, then basically you might scratch the actual disk platter.
And then you add a bunch of drives to it and it basically becomes immobile. Yeah,
and that's a very like prosaic thing that not many people think about. There is equipment in IT, like even routers, which basically you need to remember not to install before racking them in a rack, because then they will be basically way too heavy. Like even with disassembly, you don't unscrew everything unless you take it apart as much as possible.
You don't take the top off of it, you hit the buttons and the whole drawer slides out. With drives in it, it's going to be immobile. If you need to move it, you know, you need to set it up on a desk and test it as we're doing here. Then you have to take it completely back apart again, put the drives in safe transport, and transport it that way. If you transport this with drives installed, it's metal on the inside, not drive on drive metal, but it is metal on the side of the case. Vibrations are the enemy of computer equipment. Vibrations is what will kill things, and it's the same sort of drive-on-drive clack. When you realize that vibrations are the #1 enemy of longevity and reliability in computer equipment, you start to think about things a little differently. Maybe you're going to move your stuff into place with something like this. You can do that, but it should be boxed up in its original packing foam so that the vibrations are absorbed. Maybe you have a crash cart? My, how the turntables This is actually the party cart, but if you have a crash cart like this in the data center, even putting the server naked on this, it's still going to endure a lot of vibrations and it's not good. Doubly so if the hard drives are installed. Do not transport or move one of these with the hard drives installed. The longevity of all of the drives will thank you, and or your CTO will thank you for doing it that way. Always pull the drives from the chassis, put them in their proper packing boxes, and transport them that way, and then transport the chassis, and then reassemble in the rack. It's got a fancy drawer. Use the fancy drawer. It's amazing.
Yeah, and one other important thing, if you are like powering down a running system, make sure the platters have stopped spinning.
Just roll with it. It's good. Even if you got a good crash card, it's not good enough. Party!
I mean, also he's still, I think, having it good because his floor is basically a smooth concrete. If you have like tiles or anything like that, that's even worse.
Let's take for a second to appreciate just how anachronistic mechanical hard drives are. This is a precision mechanical instrument. It has a motor in it. Well, two motors. Well, a motor as you think of a motor, and a voice coil, and it can access with precision 250 trillion bits on those spinning platters. It's the Rube Goldberg machine of storage devices. I can't even believe it. How insane is it that it's like a pocket watch.
Well, not really bits, sectors more like. I don't think we've been ever accessing single bits in a drive since a very long time.
It's like, oh, here's your grandfather's precision yes, this 250 trillion bits stored with helium. Like, what kind of mad, crazy science is this? That this is it's steampunk. It's basically living steampunk. So this is one of the things to be aware of in your chassis. This can die. This is a port multiplier. See, we've only got 24 SAS channels at the back, but there's 90 drives here. How does that work? Well, that's what these are for. These take those serial attached SCSI channels and break them out into 3 zones. There's a zone here, a zone here, and a zone here.
Hey, good day to you too.
And if you were going to run SAS, you would need, to fully populate it. But each one of these drives is not really a dedicated path all the way back to the system. And so if you do the math really quick, we have 28.8 gigabytes per second with our 24 SAS 1.2 channels, which means that each drive individually can manage about 300 megabytes per second before it bottlenecks. And so if you're going to fully populate this, it really only makes sense to populate it with normal drives. Dual actuator drives can move at 500 megabytes per second plus. SATA SSDs can move at 550 megabytes per second plus, and serial attached SCSI SAS SSDs can move at least 600 megabytes per second, some of them upwards of 1.2 gigabytes per second. And so all of those things in this kind of a chassis would bottleneck. This is really just a bunch of disks. It's in the name. Disks, not SATA, not solid state, but spinning rust.
I mean, I do think that there are solutions for NVMe or SSD disk shelves, but they are mostly proprietary, with proprietary connectors and stuff like that. There are ways to extend like storage solutions like that, but those are mostly proprietary.
And so on the forum, we talk about configuring this thing. Now it's got an Ethernet port on the back, and you plug that in, and you'll want to update the firmware, and you'll want to update the out-of-band management. Those are 2 different firmware images. This, because it has 3 different zones in it, you don't have to use all 3 zones. If you just have one 16-channel external controller, you can make all the drives available. But the front zone will have double the bandwidth as the 2 rear zones when you do that. Otherwise, you need 2, 4, 6 groups of 4 serial attached SCSI channels to 2 16-channel controllers, and you end up using 12 channels on each controller, which is fine. That gives you a little bit of redundancy. But how you cable that is important, and there's a diagram for that on the forum. So you want to look at that and use that in order to get the maximum best possible performance. If the maximum best possible performance is not important to you, then it is possible to configure other zone configurations and just make all of the drives available even on a single group of SAS channels. Like, that's fine. But for the benchmarks and everything else we did the optimal bandwidth configuration so that there was no bottleneck as much as we possibly could in this chassis, and we used all 24 SAS lanes. So there's your out-of-band management port that you can load your firmware update to, and then you've also got your 3 groups of 2 for your.
This is such a stupid, nice thing. Is it like a physical button that can allow you to change IPMI, DHCP, and static on the fly with a physical button? Because if it is, it's the coolest thing ever.
Your serial attached SCSI channels, your A, B, and C. And depending on how you want to cable it and what you're using for your controller, you know, like I say, you can use an 8 or a 16 channel controller up to 24 for optimal bandwidth. If you're not going to fully load this with drives, then you can get away with 16 drives and full bandwidth. Just know that that third zone is not necessarily going to be there or work for you. And then for fans, these are pretty standard fan modules. There's 6 of them. There's actually 2 fans in here, so this works really well for cooling. Dual 2,000 watt power supplies, also from Supermicro. These are infinitely standard and will be available from now until the end of time. These are 8 plus titanium, so very, very good power supplies. 2,000 watts, 120 or 240 volts.
Yeah, 2K watts power supply, pretty standard if you want to run 60 or whatever HDDs. Sorry, 90.
These chassis from Server Part Deals, they're the real deal. And if one chassis isn't enough for you, 2 petabytes, 1.5 petabytes in 4U, you can actually connect up to 3 of these, as you can see in the diagrams, also in the how-to on the forum at level 1. So, you know, 7.5 petabytes in 3 times 4U plus the controller node, yeah, that's pretty nuts. Now, for the controller node on this, you can go traditional EPYC, AMD EPYC, especially the F-series CPUs. Those are a good choice. Just to see how much we can get out of it, I'm going to start by using a 16-core AMD EPYC in the AM5 socket. Yeah, the new AM5 EPYC CPUs. If you're just using this as a backup server, the 16-core will get it done. 64 gigs of memory, well, 96 gigs of memory. You can get a lot done with that. And so that we're going to roll with that for our initial setup and our benchmarks.
I can imagine that saturating such a JBOD with HDDs can be done fairly easily.
Pretty much the only option that I'd recommend for the controller is the LSI 9516i, 9500 series. These are SAS 12, 16 channels. Ideally, you have 2 of them so that you have, you know, a total of 32 channels. You're only going to use 24 of them. But hey, a little redundancy, a little controller failure, it never hurt anybody. These controllers do expect server levels of airflow. So if you're DIYing some sort of a control node for this, just understand you're going to have to point a fan at these cards because they do get warm. They don't have their own cooling. If they were using a desktop computer, they absolutely would need their own cooling solution because they do get really warm and toasty. Now, for this kind of a layout.
Yeah, I think like even recently, this has been something that's been bugging me, even at work, because yeah, typically server-grade PCI cards expect airflow to be already existing in a case, and there are sometimes a variation of those cards where they are like made with typical desktop in mind, and they have their own like little fan or whatever, but sometimes I do see people being very surprised at that, and very often my suggestion is, instead of putting those types of cards in a desktop, try to find a chassis that actually supports like airflow or whatever.
Yeah. Again, generally, I'm recommending that you only use 88 of the 90 slots, and you reserve the other 2 slots either for hot spares, which means that you add drives and the system doesn't use them until something goes wrong with the other drives. When this baby hits 88 drives, you're going to see some serious or you keep them empty so that when you do have a drive problem, you can put a drive in the empty slot and let it image. One of the things with ZFS, which is what I recommend for this project, for your file system, for this kind of geometry, it sort of goes without saying, you should check out our other ZFS content, is that when you have a drive anomaly, generally it's better than pulling the drive that had the anomaly. You just add a drive and let ZFS move the stuff from the drive that had an anomaly.
I do have to say there are so many interesting file systems that basically get almost no coverage. And I would really love to see somebody talking more about, you know, something other than ZFS, right? Like BGFS, GlusterFS, Luster. I know ZFS is very mainstream and obviously more accessible to people. But there are some other interesting solutions you can do.
Or the drive that disappeared, it'll recreate it somewhere else. You've got the option also of running different RAID Z configurations. You could, well, I mean, with this many drives, you could do a striped mirror configuration, which will be absurdly fast. But again, probably not. Like this kind of a chassis for a striped mirror configuration probably doesn't make sense because of the sound.
Also, I would, if you have 90 drives, 60 drives, whatever, personally, I would highly advise against ZFS. I would rather suggest, personally, I would rather do something that's more similar to Ceph. Because in ZFS, you basically have to say, those are my drives. It's like 90 or 60 drives. Configure like striped 2 or whatever, right? And from that point on, you need to maintain those 90 drives, and you have like 2 drives fault tolerancy. So basically, you cannot really scale well your storage solution like that, which always is bugging me, especially, you know, if you are like in a corporate environment. Yeah, obviously, if you have like money for a project or money for upkeep and maintenance, then sure, do whatever. But typically what happens, you know, is that either the money runs out or those disks can fail in a cascade. And personally, I really like Ceph more for that, because basically, let's say 2 drives fail. Okay, then Ceph marks those as failed and then rebalances its storage to a point where every data chunk or whatever still has 2 replicas or whatever on the remaining drives if you have spare space. And then after it's done doing that, you can either replace those failed drives or you can leave it at that, and then let's say another 2 drives can fail. And then it would repeat the process. Obviously, your usable space is shrinking down, but it's not a process where, you know, if for some reason more than 2 drives fail within like a week and you still haven't gotten the replacements yet, obviously you should be keeping some, you know, just in case. And that's what I think he's been saying with the hot spares. Sometimes you just don't put the drives in just so they are not spinning, and in theory they are not, you know, become more used with the time. They just are like being turned off, but still.
SAS expanders. You buy this kind of a chassis for capacity. You're not really worried about off-the-line performance. And so,
by the way, don't get me wrong, I don't think that this type of like JBot shelf is also very good for Ceph, but you know, that depends on what you're trying to achieve.
I wouldn't recommend a striped mirror configuration unless you really know what you're doing. So RAID Z, RAID Z2, RAID Z3, and multiple VDEVs. You can set it up just like it's got zones. You can stripe your drives across zones and get a lot of performance out of it. That's what we've done with the benchmark breakdown, which I'll get to in a second. You can check out the forum for more details. You can also do DRAID. Generally, you don't really use DRAID unless you've got a very large number of disks, but this is a very large number of disks. And if you want to maximize your space, you could do, you know, a 3 drive, like DRAID 3, and then keep 2 drives as spare. And so you end up getting something like 85 of your drives worth of capacity, and any 3 drives across the whole pool can fail. That's perfectly fine and reasonable. But to get into these specifics with the VDEV configuration and everything like that, I'm going to have to get to a terminal so that we can talk a little bit more about specifics and what we saw with FIO.
I would say this, anyway, this screams, please do Ceph. Please use me for Ceph. Please say that this, like, an alternative for that is Ceph.
We're using this little thing, it's AM5. Epic is a thing for AM5. This has got 2 of our 8-channel LSI SAS controllers. I just have to unpack a lot of cables.
God damn, I love this handle. Love this, love cases like that.
And then we gotta follow the helpful wiring diagram. There's a Serenity reference. 2x2 connectors of blue. So all these discs are very fast, and each pair gives us a faster connection back to all of the discs. And yeah, we just want to make sure it works.
It's burning!
It's burning!
By the way, also, you have like 90 drives in there, right? By the way, great freeze frame. You need to have a shitload of airflow because you have 90 drives, and on average, each drive is consuming 5 to 7 watts of power. So basically 90 times 5, let's go with the lower estimation, is 450 watts just of the heat, and quite possible only the idle mode when the drives are not really writing or reading anything. So that's like 500 watts of power you just need to blow through. Also having in the mind the fact that, you know, the drives in the back will have a slightly warmer air than the drives in the front.
So once you get your drive set up, you run tests. That's what you do, right? We got all kinds of tests. Even before we set up ZFS pools and everything else, you just run a lot of tests. Basic stuff. Smart CTL, Smart Mon Tools is useful for checking the drive. How many power on hours does it have? Power on hours, 27,687. Not a big deal for drives like this, 18 terabytes of storage. I mean, it's fine.
27,000 hours? How many days is that? 27,000 divided by 24 is 1,100 days, divided by 365, roughly 3 years. I would say, yeah. Maybe not brand new, but still not a bad like usage. I think that in my video that I did last year when I bought used Seagate drives, they had like, I don't know, a year, maybe 2 years of power on, and they are working flawlessly. I think the much more important parameter also is how many times they were powered on and powered off. This will give you a good inclination as to how they were used. And obviously how okay, that's basic. By the way, very interesting. I've also touched upon that in my previous video. Different disk vendors can approach the smart CTL values differently, and the Seagates I think I've bought were reporting how much data they've written overall in the read error parameter. But that's something you need to basically go through for each vendor and for each drive, and make sure that you actually understand what smart CTL is showing, because vendors don't really respect the smart CTL names, parameter names. They can just use them for whatever, and then have proprietary software like C-Chest, I think, from Seagate to actually read that out and give you like proper description.
You get a warranty from server part deals. The helium level looks good. I also like to do a test. So with the way we've got it cabled, there should be no bottlenecks. So I've selected 24 drives basically along the center column, and we're going to run a read test on all 24 of them simultaneously. And basically you're looking for about 200, 250 megabytes per second from every drive. And we can see, boom, all 24 of the drives that are randomly selected in our chassis are running at full speed. And so this tells me that every channel that's connected across both controllers is working correctly. I'll do some more tests like this with...
By the way, notice that those like def, SDM, SDAD, basically it's running out of letters from A to Z. Typically you have SDA to S to Z or SDX. So what's Linux doing? It's adding another letter, and you basically SDAA, SDAB, etc.
Some more randomly selected drives just to make sure there's nothing really strange going on, but generally this should work like this. Now sometimes you run this test and you'll get an absurdly low result. The drive may have been doing something in the background, or the connections may be asleep. If you only test one drive at a time, it might be oddly slow, and that's because the link's powered down to save power. And so it's using so little bandwidth with just one drive active, you may have to run it a couple of times for the chassis to wake up. But this looks pretty good. Let's get somewhere a little quieter and back to the terminal. Actually, this is astonishingly quiet considering it's a petabyte. Like,
Agree.
Somebody almost wouldn't complain about this if it was on their desk. Almost.
Yep, 20 volts and 0.57 amps, so that gives you 6 to almost 7 watts of power per drive.
$90 drives? It shows us 180. Well, it depends on where you check. If you look in disk by ID, you'll only see 90, but if you look in disks by connection, you'll see 180, and that's because there's a redundant path provided by the chassis. Even though we don't have a fully redundant path with 6 connections to the 2 controllers, we kind of do have a redundant path, even though this chassis is not configured with the extra redundant path interface. Like, we should have that. It would be nice to have that. But if we really wanted true full redundancy, along with the interface cards, but even in this configuration, you do have a redundant path to each drive, at least part of the way. Okay, so we did our smoke test and we did our burn-in test. Can I get 250 megabytes per second from basically all 90 disks at the same time? Basically, yeah. It performs really well. I've got a Z-pool created. I've got 9 VDEVs of 10 devices each, RAID Z2. And so this is one of the best performing, best balanced pools that you have, but I've already violated my own rule. I'm using all 90 disks. I didn't leave any spares. But the nice thing with this is that any 2 disks could fail, guaranteed. If you have a third disk that fails, odds are it still won't fail. You can lose any 2 disks in any RAID Z VDEV. So if you lost 3 in one VDEV, you're going to lose the whole pool. But if I lost 2 in this VDEV and 1 in this one, the pool is still going to keep running. So that's nice. The bad thing...
Use Ceph. I know that single node Ceph is a meme, but I've done that. It works. It will be interesting to see more creators do this sort of testing with Ceph, just to see the performance gains or whatever.
With this is that I'm going to have to pull a drive that's malfunctioning or dead in order to replace it. Fortunately, the front of the drives are all etched with the serial number, so you can, like, it's pretty easy to shut the pool down and it's like, look, and it's like, ah, yes, I've confirmed that this one is the one that has disappeared. All right, that's the drive serial number that I'm looking for. So for an offline backup type solution, this is great. I know that some enterprise configurations, you really want to hot swap the drive. It's like, oh, that's really cool, but it's a lot safer to shut everything down and then just go disk by disk and just double, triple, quadruple confirm. But you can't see the front of the disk, and I mean, you could do it hot if you want.
So yes, but I think I would be surprised if this JBot doesn't have a functionality of lighting a LED diode, which basically tells you that, okay, this drive with this serial number in this slot is this drive you want. This is a LED lighting up, telling you it's this one. I'd be surprised if it doesn't have that.
If you want to live dangerously, but if you want to play it safe, you can shut everything down and do it that way.
Also, I'm not sure what he means by shutting it down. I would advise against like complete power down of especially 90 drive JBOD, because especially if you have drives that have been working for a longer period of time, let's say not 3 years but 6, 7, 8, 10, there are deployments where that happens. The thing that's killing the mechanical drive the most is powering on and off, the spin up and spin down. I think that whenever we've had some power problems in racks in data center that caused the whole storage rack to spin down, basically go dark, go offline, we've had the most disk failures after it turned back on and those drives started spinning again. I think we've had as much disk fails in a single month as previously we've used to have during few years.
Just doing a couple quick FIO tests without a lot of complexity. Things are looking pretty good, but I'm actually going to have to run something a little bit more complicated to test our IOPS and latency and everything else, and that's bench FIO. And that's something I want to get into in another video, but I'm also curious about what disk configurations you want to see. I want to test this RAID Z2, this 9 VDEV wide RAID Z2 configuration, but I'm also thinking about a couple of specific DRAID configurations.
I think you know my answer. And by the way, like the video, definitely. Level 1 Techs, one of the best YouTubers that talks about enterprise gear.
And I mean, maybe we could throw in a striped mirror just for fun. It's only 45 drives of capacity, but we would actually be using, that's sort of the maximum speed. And then any one disk can fail. And chances are, if a second disk failed, it wouldn't be fatal. But there's a small chance that, just a few percentage points that it would be fatal if a second disk died. And then maybe some RAID Z3 configurations just to see how that works. So it's going to take a little while to run these, as it turns out.
Yeah, also I don't really like because I see what he's doing here, but like he's splitting those drives into a smaller pools, and in theory you could also like build pools on top of those RAID groups. But basically you still can't, with this configuration, you still cannot get away from the fact that within a single grouping of disks, 2 drives can fail. And you really, like, in this approach, need to put abstraction over an abstraction to achieve possibly better, disk resiliency.
Because with disks this large, it's like, oh, I'll just do a 100 gigabyte test. And it's like, that's a little misleading. You really need to test like a terabyte or 2 or 3 at a time when you have 90 disks that are 18 terabytes each. Even just testing here, it's like we've used 8.24 terabytes, but I've still got 1.09 petabytes of availability. I mean, without really even doing much, 5,000 megabytes per second.
By the way, I haven't noticed, is he doing with FIO block level tests or file system tests?
On a ZFS file system? Do you know how absurd that is?
File system, okay.
From a mechanical file system, that is just completely insane. And remember, this is an AM5 system that doesn't have a lot of RAM. It would be even faster with a true EPYC CPU and lots of RAM. Even just doing some quick testing here, I mean, I've already used 8.24 terabytes, and there's just over a petabyte still available. And to get really good testing, you really need to put a lot of information in the pool. So that's going to take a little bit when you've got an array this large, because, it's fun. So stay tuned for part 2. Get subscribed, check that out. Maybe go check out some stuff on Server Part Deals. You don't have to buy a petabyte at a time, but I haven't had a disk die yet, and I've been doing bad things to them for several weeks now. So we'll see. All right, signing out.
Okay, yep, definitely I want him to do a part 2, but by the way, let me just show you as a closing note what I'm talking about. I know that Seth can be a bit of a monster, but and like you said, you don't have to do a petabyte at a time, but basically you have to do a disk group at a time. So you cannot buy one drive and just add it. You need to buy, I don't know, 5, 6, like whatever you do, whatever you will define your group as. Just let me show you, but I need to find, I don't remember what was my my address. Just let me verify that quickly. And by the way, I think this will be enough for today. I don't really want to keep watching because technical stuff is not really digested well. Oof. For a second there, I thought I forgot my own password. This is a single node Ceph instance I've built. Basically, let me show you in this video. So this is the server, even if it has like the motherboard taken out, it's built on some legacy CPUs, like some old AMDs. And it has like almost all of those drives fit in. The cool thing about that, and I think that this is also a very cool thing about a JBOD or a disk shelf, is that you can put in a mix of disks, right? So here I have some Seagates that are terabyte in size, some Seagates that are 4 terabytes in size, right? I have some Seagates that are, I don't even think those are Seagates that are 2 terabytes in size. I think I also have like, yeah, some HPs also. And all of that lives in single harmony. Granted that, you know, with physical platter, you don't really want extra, like some crazy performance, right? If you want that, you either need to add some SSD or NVMe caching, or just basically build an SSD or NVMe by itself. But I do think that with proper tuning, Ceph can give you better data resiliency with less headache when it comes to planning out the groups, etc. And you know, especially if you are doing that for archival reasons or whatever, it's great. Like right now, I have like 47 out of 21 terabytes utilized. The cool thing is, like I was saying, is that if you pull out a drive, because obviously in Ceph you also like define how many drives you can fail before you will lose any data. But the cool thing is that first of all, you can have like a mix and match of different types of drives and sizes. It's not recommended, obviously, but you can do that. The other thing is that if I take out 2 drives and let's say they failed, I can go to Ceph and say, okay, those 2 drives are gone. Now you have 2 drives less to work with, and those drives will not come back. Commit. Like, delete those old ones, forget them. Now work with what you have. The Ceph will move those placement groups, basically this thing here, and make sure that all of that data that has survived still, like, obviously this parameter here will decrease. Like, instead of 21 terabytes, there will be like, I don't know, 90, let's say, whatever. But you will still have that redundancy you've defined in the first place. After that, you know, rebalancing is done, and you will be able to keep on living, right? And if your extra cache will arrive sometime later, you can buy 2 drives, 4 drives, single drive, put it in, add it to the pool, And then Ceph also automatically resleeves, rebalances everything. And voila, right? And like, especially if you are not too deeply worried about performance, like this is not a, for example, if this is not a storage server that you are using to mount on some, let's say, editing workstations where, you know, editors need to basically all access 4K raw materials or whatever, but you just want like a semi-performant long-term storage, long-term archive, perfect. Like with some proper minimalistic tuning, this can be done on a single server. You don't really need to distribute everything across multiple servers. Granted, for Ceph, you need to have some stronger CPU and more RAM, but this goes for any other storage server, I would say. Okay, well,
You can find me in the level 1 forums.
very good video, very good reporting. I think like YouTube and IT definitely needs more of that, and you know, more stuff like this, less Python tutorials, right? Zero to hero or whatever programmer stuff, because this type of knowledge is very hard to acquire unless you are working in the business. If you want to get trained on that, you know, it's very difficult. But you know, those people that have that knowledge are, I don't want to say very highly sought after, because you know, one admin can supervise 30 software developers. That may change though, but still. And like I said, I think I'll skip the rest of the stuff I wanted to watch for today, since it's getting fairly late and I wasted a lot of time debugging the camera problems today. It does seem that I've solved those problems. Camera is working fine. Sadly, I switched from the HDMI grabber, capture card, Elgato, whatever, to the inbuilt USB-C webcam function, which I think is a bit less sharp compared to what I've had previously on the HDMI grabber, but still, I think it's nice. Well, that's it for today. I'll try to stream more often, maybe tomorrow, we'll see. And with that, I hope I'll see you next time.